Hey, grade 8. So today we'll talk about the rest of the laws of exponents. So I want to refresh your memory from the product of powers and quotient rule for exponents. So we know that an exponent looks like this, 8 to the power of 2 or 8 squared, 8 being the base, and the exponent or the power or the index is the 2. Just a refresher. Alright, so we talked about two rules or two laws of exponents. We talked about product of powers. That means if you have the same base and you're multiplying them, but you have different exponents, what you're going to do is keep the base and you add the exponents, like this Power Ranger looking poster there. In the quotient rule, it meant that if you had the same base but you had different powers and you're dividing, what you do is keep the base and you subtract the powers, the top minus the bottom. So for example, 2 to the power of 5 divided by 2 to the power of 3, keep the 2, 5 minus 3, the top minus bottom. That gives you 2 to the power of 2, which means 4. Okay? And I want to talk to you guys about where do we use exponents. So in my my video of when am I going to use this, I talked about how exponents are very useful. We talk about it every day in different careers and different fields, but people don't point out, okay, that's an exponent. But you might get surprised and, oh, we actually talk about exponents and we didn't know that it was talking about exponents. For example, here's an example from your textbook. It says there are 20 bacteria in a given sample in a lab during the early phase of culture growth. The number of bacteria keeps doubling every hour. How many bacteria are there after 3 hours? Write your answer in exponential notation. So, the spreading or the multiplying of bacteria here is similar to the COVID cases or the virus, right? So it multiplies, it doubles, or it quadruples. So we're going to represent that in exponential notation. Okay, so we start with 20 bacteria. It says after an hour, the bacteria doubles. So from 20, it becomes 40. Okay, and then it's gonna double again. So it doubles every hour. The second hour is gonna double again. So that means 40 times 2, which is 80. Or you can also think about it as this, the green, 20 times 2. Then we're gonna double it, right? And it's gonna keep going and going. It's gonna double and double and double. So they're asking, so after 3 hours, how many bacteria are there? So again, it's pretty easy. You can just keep this 20 times 2 times 2. So this thing times 2, right? Because we're just doubling what we had here. Or you could also say 80 times 2, which is 160. That's a lot of bacteria. So how do we rewrite it? As an exponential notation. So here we can put 20 times, there are 3 2's there. You can also think about it, it doubles for 3 hours. So it keeps doubling. You double the first time, the second time, the third time. Okay, you can also break this down too. So 20 is 4 times 5 times 2 to the power of 3. We can rewrite 4 as 2 to the power of 2 times 5 times 2 to the power of 3. Sorry, it's messy. Let's combine the 2's, shall we? We know that 2 to the power of 2 times 2 to the power of 3. Keep the base, add the powers, and the 5 still outside. So it's 2 to the power of 5 times 5. There you go. That's how much bacteria we have after 3 hours. Okay, so we just did that there. I just wanted to point out that you can rewrite integers and prime factors. So some of you guys might recall the prime factor tree. Some of you have learned it like this, but I learned it this way here. So what you can do is 900, you split it into 2, you can be doing 2 and 450, and then 2 and 225, and then 3 to 75, 5 times 25, 5 times 5. So the reason why I did that, because the outsides of the tree here are prime factors. Same with this here. The outsides are the prime factors. So I didn't write 1 here because it would be redundant. So you can include it, but usually people don't. So you need to rewrite the 900. So we have 2 2's times 3, and there are 3 5's. So as you can see this way as well. So that's when we also use exponents to look at the prime factors. Alright, so today I'm going to talk to you guys about 3 different rules of exponents. So the first one here, we'll talk about the power of a power. Again, a refresher. The base here on y to the power of 3 is y, and the exponent is 3. So what if I tell you guys, if I were to expand 5 to the power of 3 to the power of 4. So for y cubed, it's easy, right? You just multiply the base by itself 3 times. So 5 to the power of 3 to the power of 4 is the same concept of y to the power of 3. You just multiply the base by itself 4 times because of that power, right? Okay, alright. So use the blank of a power property. So in this case, use the power of a power property. That's 3 powers. Okay, so how do we calculate that? So remember from the first slide here, the product of powers, if you have the same base and you're multiplying, you just add the exponents. So keep the base, add all the exponents, and you will get 5 to the power of 12. So that's your answer. So if I were to ask you to simplify, and I will allow you to have a calculator, you can put 5 to the power of 12. That is a big number. Okay. And it makes sense, right? So this is 24,414,000, and oh, that is not even 244 million. Okay, 244 million. So if you think about it, that's really rapid, right? If you think about it, if the cases of COVID-19 quintuples, right? I think the 5 times. So it multiplies 5 times each day for 12 days. The cases would get 244,140,625 at least. Okay, if we started with 1 person and it multiplies by 5 every single day for 12 days, we would end up with that many cases, and that's a lot of people. All right, so how about this one? I want you guys to try that one out. And you were right. What I would do is I'm gonna do 3p to the power of 5, and I'm going to multiply that 4 times by itself. Okay. This, that, okay. All right. So, as you may have noticed, that we also needed to multiply 3p by itself 5 times, right? So I'm gonna do this once, and I'm gonna see a pattern for all those 4, because nobody got time for writing all those 3p's, right? So 3p multiplied by itself 5 times. Yeah, if you guys had this feature on your notebooks, that'd be awesome. I mean, you could do it on your OneNote actually. So that's 1, 2, 3, 4, 5. Okay, we had too many. Okay, so gather all the 3's. That's 1, 2, 3, 4, 5. And gather all the p's. That's 1, 2, 3, 4, 5. So actually, 3p to the power of 5 is 3 to the power of 5 and p to the power of 5. So we're going to do that for all of these 3p's. Yeah, now you guys can see how it'd be really handy if you know the laws of exponents, because again, no one wants to sit down the whole day to expand all of these, right? Okay, so again, we've talked about this. If you have the same basis, you just keep the base and add all the exponents. Okay, so I'm gonna separate the 3's and the p's. 1, 2, 3, 4. Okay, so we have 3 to the power of 1, 2, 3, 4. 4 times 5, that's 20, times p to the power of 20 as well. Okay, all right, let's pause for a moment and look at the pattern. Okay, so let's go back to the first one. The first one says 5 to the power of 3 to the power of 4 is 5 to 12. And the second one says 3p to the power of 5 to the power of 4. What do you guys notice? Power to a power. You should notice that power to a power, what you're doing is you're just multiplying the power to the power. So that's 5 to the power of 12. And this one, this is what you're doing. 3p to the power of 5 times 4. So that's 3p to the power of 20. And watch this. 3 to the power of 1, p to the power of 1, right? And we multiply 3p by itself 20 times. That means we have 23's and 20p's. That's how we get that. So in general, let me rewrite this. So in general, the power of a power is this. So if you have a times b to the power of, well, let's do this. A to the power of n to the power of m is equal to a times m to the power of m times n. That's it. You just multiply the powers. So go ahead and practice with these 2 examples, and I'll reveal the answers. Alright, so the first one, you just multiply 4 times 7, so that's 28. And you can even simplify it with this. Okay, I don't want you guys to expand this 28 times, but notice this. If I were to raise negative y to the power of 2, that's negative y times negative y, right? So we have two negatives, that makes it positive y squared. So what if I have 3? So we expand that, and we know this is y squared times negative y. That's negative y cubed, right? So if you do that to the power of 4, we know that negative y times negative y squared, multiply that by y squared. Okay, so notice the pattern. If the exponent is even, it will be positive. But if the exponent is odd, it will be negative, because the number of negatives there is odd, so it will be a negative. So in this case, negative y to the power of 28, if you simplify it, it will be y to the power of 28. Another thing that you can do as well, negative y is pretty much negative 1 times y to the power of 28. So you just multiply by their own exponents. So negative 1 to the power of 28, again, that's positive. Okay, so this second one here is different. So again, you need to multiply the exponents, power to a power. You get c to the power of 28 times c to the power of 12, and then 6c squared. 6c squared here, the exponent 2 only belongs to the c, because it has no parentheses. So what do we do here? Gather up all of your c's. So again, this is pretty much saying 6 times c squared, right? So I'm gonna pull up the c squared here, divided by 6. Okay. Or you can also do this. C to the power of 28 times c to the power of 12. Sorry, this was supposed to be 6 times c squared, like that. Okay, so we're gonna use the first one here, product of powers, and then we're gonna do the quotient rule for exponents. So product of powers, say if you have the same base, keep the base, add the powers, and then we're gonna isolate the 6 there and c squared here. So 1/6 times c to the power of 40 divided by c squared. So you just subtract 40 minus 2, so that's 1/6 times c to the power of 38. That's your answer. Alright, so I'll see you guys in the next video.